All right, so this week we are going to be using the patterns that we already established for single replacement, double replacement, specifically today, but then also synthesis, decomposition, and combustion, to write the products based on the patterns that we know will happen, and a couple of tools that will tell us if the reaction will occur or not. Also, my 1-year-old daughter Avery's awake right now, so you might hear her little sounds and saying hi. Hi, honey. So we're going to start out with single replacement reactions. And we know that a single replacement reaction is a reaction where an element and an ionic compound swap partners. So our generic form is element A plus compound BC swaps partners, and let's say A bumps out B. Now we have B is by itself, and AC is our new compound. So whenever we're working with the activity, the single replacement reactions, we are going to notice the activity series, which is over here. We're going to make note of that, and it will tell us if a reaction occurs or not, depending on what element is trying to get into the compound. So with the activity series, we want to compare the two atoms that will be changing places. And the way the activity series is set up is it already compares metals with metals and nonmetals with nonmetals. So if your element is on the metal side, it's only going to switch with a metal, and same for a nonmetal. So check what the element is, and then it will tell you if it's a metal, it's going to switch with a metal, and vice versa. So first you want to compare the two atoms that will be changing or swap places. Okay. And just like I said, metals will replace metals and nonmetals will replace nonmetals. And this is so that our ionic compound in the products and in the reactants, really, both of them have to have a cation and an anion, a metal and a nonmetal. So when you swap a metal, it has to replace its same kind. So when we're looking at the activity series, the element higher on the activity series will be in the final compound. So if I'm comparing, actually let's just look at our example, the first one, aluminum and lead chloride. Aluminum is here, it's a metal, so I have to compare it to the metal in my compound, which is lead. So I've got aluminum and lead. According to our rule here, let's write it down. Element higher is in the compound in the products. Higher element is in the final compound. So our aluminum is higher, so it needs to be in the compound on the product side. So this reaction will occur. If aluminum was already in the compound, then we would just write no reaction, and because it already is in the compound and nothing will change. So to write our new products, we know that aluminum is going to bump out the lead, and the aluminum is going to take the place of the lead. Now, I often see students just copy down exactly as they saw the compound from the beginning, including subscripts. However, that is not correct. The way that we write ionic compounds does not change from earlier in the semester, where we look at the ions and do the swap. So the reason this has a 2 in this lead chloride is because our lead has a positive 2 charge and the chlorine has a negative 1, and they do the crisscross method. But that's not the charges for aluminum and chlorine. The charge for aluminum and chlorine is positive 3 and negative 1. So when we do the crisscross method, our compound will end up being aluminum chloride, that's with a 3. Okay? So of course, this makes our compound not balanced. For today, we're just focusing on making the new patterns. However, moving forward, we will balance them. I believe, let's see, did I make a note of it? No. Okay, so we will balance these together in class on Friday. just practicing balancing before we do our lab. So go ahead and try it and see if you can get them balanced. But like I said, I want you to focus on the pattern, not necessarily all the numbers right now. I just want you to focus on will it switch and using the activity series correctly. So that is our single replacement reactions. Let's do a few more examples here. So we've got sodium bromide and fluorine. So our element is a nonmetal. That means we're going to be working on this nonmetal side now. So we're going to be matching up sodium or bromine. It's bromine is the nonmetal. So we're going to compare these two. Fluorine's higher. It needs to be in our final compound. So this will become sodium and sodium fluoride and bromine. Okay. Now sometimes I see students accidentally pair up the ones that they're supposed to compare, like I actually almost did, and then they have two nonmetals together, but that's not a correct ionic compound because it has two nonmetals. It has two anions, and that's not how we write an ionic compound. So just make sure that your compound has both a metal and a nonmetal. And this one actually does keep all of the subscripts the same because they're all the same charge, and both of our elements are diatomic. So just to reiterate, there are 7 diatomic elements. Whenever they are an element, they'll have a 2 next to them. Lead is not one of those, and neither is aluminum. That's why they're just elements without any subscript. However, fluorine and bromine both are part of the diatomic 7. So just to remind you, it's hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And we've done this. We've been working on memorizing these a lot. So those 7, this is why we've memorized them, so that we can use them correctly in writing these products. Okay, next one, we've got magnesium is the element, so that's over here. It means we need to compare it to the metal, potassium. So whichever one is higher will be in the compound. That would be potassium. However, it is already in that compound, so this would actually be no reaction, and you don't have to make any swap because potassium is already in the compound. Done. Lithium is also a metal, so let's check over here. And copper. So lithium needs to be in the compound. It is not, so it'll go ahead and proceed with a reaction. Copper gets bumped, and it's not diatomic, which is why we just write Cu. And then we have lithium and carbonate. Think about their ions. Lithium is a +1. Carbonate is a -2. So when I do a crisscross method, this is just my work, by the way. When I do the crisscross method, my actual compound is lithium with a little 2 and then 1 carbonate. So there's my compound. And again, yes, this makes it not balanced. However, we can use coefficients to fix that. Just putting a little 2 there solves it nicely. Again, we're not really focusing on the balancing right now, just the patterns, but I wanted to clarify that so we're not confused. It does still follow the law of conservation of mass. And our last one, we have bromine is our element, so we're on the non-metal side, and chlorine is what we're comparing it to. Chlorine's higher, so it needs to be in the compound, already is, no reaction, done. So that's how we do single replacement reactions. You compare, then you make the swap. Make sure you follow the crisscross method. Always use the crisscross method for your products, for those compounds in the products with their charges. Don't just carry over what you saw in the products. Charges of different metals are different. Okay? And that's to write compounds. Okay, I'm going to stop here and make another video for the double replacement. So if you would like to try your hand at some of the single replacement examples, you can work on page 4. That's what we just worked on using the activity series, actually 4 and 5. I am going to have you choose 8 of them. So any 8 of our single replacement, and then same for double when we get there. But like I said, I'm going to make another video to do our focus on double replacement.